Okay, hi everyone. As I said, good morning, good afternoon, good evening, depending on where you are in the world. Welcome to today's CNCF webinar, Take the Pain Out of Multi-Cluster Kubernetes with Lens. I'm Christy Tan, and I'll be moderating today's webinar. We would like to welcome our presenter today, Edward, I don't know, hopefully I didn't butcher that, Edward, Developer Relations at Mirantis. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There's a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and slides will be hosted later today to the CNCF webinars page at cncf.io/webinars. With that, I'll hand it over to Edward to kick off today's presentation. Take it away.
Thank you, Christy. And I would like to thank everybody here for actually having me participate in this CNCF webinar. I'm very excited to show you guys how we can take the pain out of multi-cluster Kubernetes with an open source technology called Lens. As Christy mentioned, I'm Edward ENL, and I'll be walking you guys through a demo today. So I'm looking forward to sharing with you guys my tips and tricks for taking out the pain of multi-cluster Kubernetes with Lens. Let's get started. Oops. It's going the wrong way. Sorry, guys. So about me. I'm responsible for developer relations here at Mirantis, and my day-to-day responsibilities is to really seek out the pain points within Kubernetes to help streamline developer and operator initiatives. I'm by no means an experienced Kubernetes hacker, but I do have above average understanding of Kubernetes and all of the objects that relate to it. Cool. Sorry about that, guys. So the Kubernetes challenge. People and organizations invest in Kubernetes, but developers may think it is too complicated and adoption is slow. With other Kubernetes-focused tools, you have to know what you're looking for. In order for Kubernetes to be effective, users traditionally need quite a bit of training and understanding of all Kubernetes objects and how they relate with each other, thus causing somewhat of a complication between organizations and teams. So you may not be seeing the return on investment that you should with your container initiatives. Oh. So this is Lens. Lens is a developer-friendly desktop application for all of your Kubernetes platforms. It's 100% open source, and it works with any Kubernetes distribution from GKE to EKS, Rancher, and Mirantis Container Cloud. It allows developers and operators to easily onboard and operate their applications in Kubernetes, thus improving productivity and increasing overall return of investment on their container initiatives. Wow, that actually worked. Sorry, guys. So this is a quick stat sheet of where we stand with Lens today. It's the world's most popular Kubernetes integrated development environment. We are actually self-proclaiming that, but we have some stats to back us up. As you guys can see, we currently have over 9,300 GitHub Stargazers. I think actually as of today, it's more like 9,500 GitHub Stargazers. We currently have 92,000 users that are currently using the application. And we have over 1.2 million downloads currently. Our goal is to increase this number significantly, and we really want to allow developers and operators to work much more efficiently while working with Kubernetes and their container initiatives. It does not want to work today. So what are we going to be reviewing today? Today, we're going to be doing a demo-rich webinar where I'll be sharing my tips and tricks and best practices for working with multiple clusters, from multi-cluster management through Lens's Smart Console, our context-aware terminal, which matches to the correct endpoint of the cluster, deploying the application with Helm directly into Lens and your cluster via 1 or 2 clicks, and our newest functionality that should be releasing tomorrow is our Lens Extension API. So since our slides don't want to work too much, I think it's a good idea to just jump into the demo itself. And towards the end, I will also be sharing with you guys how to actually find the Lens repo within GitHub and our contact information if you have any further questions post-webinar. Without further ado, guys, let's jump into the webinar and the demo. So first thing we traditionally like to do is obviously add our cluster to Lens. Lens utilizes your role-based access control from your cluster and your kubeconfig file. There's 2 ways to add a cluster to Lens. You can select the kubeconfig file on your operating system, or you have the ability to paste it as text here. For demonstration purposes, I will find my cluster. This looks like the correct one. Use configuration. And very simply, we just add our cluster to Lens. Before jumping into the demo-rich webinar itself, I do want to highlight our cluster settings. Currently, our cluster is online. The distribution says unknown, and the reason for that is this is currently a release candidate prior to our launch of 4.0 tomorrow. So the correct distribution is actually vanilla, but for now it says unknown. Our kernel version, as you guys can see, our API address, the node count within our cluster, our kubeconfig file and where it sits on a laptop or desktop. And we have some functionalities that we can change here within our settings. We can give our cluster a name. Create additional workspaces within our cluster. And the way I would think of this, as these are folders within your cluster itself for maybe staging, admin, and production clusters. You can think of it as a separation of matter of concern, and we'll add a workspace today. In order to add a workspace, you'll hit add workspace. And you guys can see I have other testing workspaces that I did this morning. And very simply, you click this file icon that says save. From here, we'll jump back to our settings, scroll further down, and we have another neat functionality within Lens as well. And I actually like this a lot. You guys can see on the left-hand side, my smart console. I have several different icons to allow me to understand which cluster I'm currently working with, from my admin cluster to my Raspberry Pi cluster, my Minikube cluster, and so forth. Simply add an icon. What kind of icon shall we add today? Let's just add a Helm chart icon. Might not be the prettiest, but that's all right. And you can see we immediately add this icon to our specific cluster to be able to navigate through our cluster selector and our smart console very, very efficiently. Lens also has a pre-built-in auto-detect Prometheus, and you have the functionality and the ability to bring your own Prometheus to Lens if you choose to do so. Okay, enough about the settings. Let's actually jump in to the demo itself and why you would want to utilize Lens for your Kubernetes initiatives. Clicking into our cluster. I'll give you guys a second to digest some of this information. But as you guys can see, we are immediately brought into our cluster overview screen, where we can see how our cluster is performing in the last hour through the pre-built-in Prometheus. From our master to our worker, our CPU, and memory as well. Let me just move this down. We can also see how many pods are being currently used within our cluster and the capacity as well. At the bottom, we have real-time events and messages that tell us what is currently going on within our cluster. This is extremely useful when you try to troubleshoot particular things within your applications, maybe your deployments, your pods, or your nodes. Lens really tells you the source of the error or warning and the message associated to help you troubleshoot very, very quickly. We'll come back to the events in a bit towards the end, but for now, we're going to walk into our nodes section. As you all can see, we currently have 5 nodes running, and we can filter by CPU, memory, disk, and so forth, all in real time. Another very, very interesting functionality within Lens is being able to get a much more granular look into a particular Kubernetes object. For example, a node. Clicking into this node brings us into this very unique user interface screen that shows us how our node is performing in the last hour. From our CPU to our memory to the disk and the pods itself. At the top left, let's have this go away. That's fine. At the top left, you guys can usually see the Kubernetes object here, as well as the name. On the right, depending on your role-based access control that we leverage from your kubeconfig file, you can do specific actions to this object itself. For example, you can shell into the node. You can cordon the node, drain, and you have the ability to jump into the Kubernetes resource manifest of this particular object. Clicking into here. We are immediately brought into the Kubernetes resource manifest, as you guys can see, which allows us to test and debug and change all in real time if we click save and close. We'll cancel this, jump back into our node, and we have some other very interesting things happening here as well. We can see all the settings associated to this Kubernetes object all in one place, from when it was created all the way down to the operating system, the image, the kernel version, the container runtime, the kubelet version, and of course, very importantly, our labels. We can see all of the pods that are also running within our node, all in one place, and we have the ability to click through each and every single object within Lens as well. So for example, if I want to take a look at this FluentTD pod itself, I can click here and we're immediately brought into a granular view of the last hour of how our particular pod is performing. Once again, from CPU to memory, network, and file system. We'll close this for now. So this is a very unique screen as well. This is our workloads overview screen where you can see different Kubernetes objects and how they're currently performing. So maybe if I'm an operator or an application owner and I want to see how my application is currently running or how my cluster is performing, I can come here and immediately get real-time insights to my application or my cluster all at once. As you guys can see, we have our pods, our deployments, our stateful sets, our daemon sets, jobs, and cron jobs. Again, at the bottom, we have our real-time events that tell us what is currently happening. As you guys can see, I have a warning message here. And that warning message actually occurred roughly 8 minutes ago. From here, we'll jump into pods. There's several ways you can do this, as you guys can imagine. You can click pods under the overview, click pods here, and also click pods in the top right. Clicking into pods brings us into a very unique screen. We immediately can see all the pods that are running within our Kubernetes cluster, from the name to the namespace, the amount of containers, what the pod is being controlled by, and the status of the pod itself. So what makes this unique and fascinating for us? Well, one of the very cool things that Lens provides for us is the ability to filter. Another very, very important thing I want to mention here is that Lens has a pre-built-in context-aware terminal. What does this mean? That means that Lens auto-magically, yes, I did say auto-magically, connects to the correct endpoint of your cluster itself. So to show that Lens does this, I will perform a little bit of kubectl to show that we are matching to the correct endpoint of the cluster. So as you guys can see, here's our endpoint and the version. And if I minimize this screen and jump back to our nodes, we can see that Lens auto-magically has matched to the correct endpoint of the cluster itself. Lens also downloads in the background the most latest and greatest kubectl that you guys can perform within the terminal. Another quick thing I like to run while within our terminal is matching our nodes. And you guys can see our nodes are matched to the correct cluster. So Lens performs this for us without having to write any command line to make sure that we are reducing user error while working within our clusters themselves. Jumping back over to workloads and the overview screen, we'll jump into pods and move forward. Lens also allows us to filter and search, as mentioned previously, for a particular pod or other Kubernetes object that we are looking for. We can select a namespace, and it immediately highlights all of the pods associated to the kube system namespace. I do want to mention here that this carries on through every single section within Lens as well. So if I move to our deployments, as you guys can see, it is currently filtering, or not filtering, but matching to the correct namespace, which is the kube system. In order to remove this, it's very similar to Excel. If any of you have used Excel, just uncheck this box. Now that we are in deployments, we will open up a deployment to view what is currently happening. The deployment that I will be opening up is the Nginx. We can view when it was created, the name, the namespace it's associated with, and various other settings here as well. Another very neat functionality that Lens does is it provides us a user interface to be able to utilize Kubernetes to scale our deployments up and down with a click. Let me show you how we do this. Scrolling to the right, we can see the scale icon. Currently, we have 3 replicas deployed for the Nginx deployment. and we want to scale this up to, let's say, 45. Clicking scale, jumping into our pods, and scrolling down, we can immediately see the containers being created without running any command line. Everything that happens within Lens is near real time as well. We'll let these deploy. And just with a simple click, Lens has utilized Kubernetes to scale our deployments. I find this extremely useful, and I think you guys will too. Going back to our deployments and our Nginx, we can see immediately that we have 45 pods currently running. From here, we also have the functionality and the ability to utilize Kubernetes to scale them down. To do so, we do the same thing, and we'll scale them back down to 4. All in real time, Lens begins to terminate these pods, as you can see here. We'll let this run. Perfect. Going back to our deployments. Again, we have the functionality here and the ability to filter and search through a click of a button or typing a particular thing. For example, and you guys can see, we get a much more granular view into our search. And why is this beneficial? I mean, technically up until now, or depending what tools you're using, you would have to write some type of kubectl to be able to understand all the objects that are currently running. So to demonstrate this, we'll do a quick command line. Open this up, and you guys can immediately see all of the objects with the specific details associated. I'm not sure about you guys, but this is quite a bit of an eyesore for myself. And to be able to filter and search here, you would have to perform other complicated command lines to be able to find this information. Lens does this for us simply by clicking and filtering and searching, thus creating a much more efficient use of our time. Clicking into another pod, we get another very useful functionality within Lens, which is being able to view all of the logs associated to this particular Kubernetes object. Opening this up, we can see all of the logs that are associated to this particular pod. Lens also gives us the ability to save this log as well. Save, and we can choose to save this to our desktop, our downloads, or wherever we choose to do so. We'll close this for now and move along. Let's open up another deployment. Let's see what deployment we want to open up. Maybe we will open up our core DNS. And again, you guys can see we get a much more granular view into this deployment and how it's performing in the last hour through the pre-built-in Prometheus. with all the settings associated. Another thing I want to highlight here is the ability to walk through each and every single Kubernetes object through a simple click. Scrolling down to our pods, we can see the 2 pods. I can click into them and immediately, once again, get a granular view into these pods. Anything that you see that is hyperlinked is clickable. We can show our tolerations. We can see our containers, the ports associated to the containers, our volumes, our config volume, and much more. So if I was working in this pod and I wanted to see what it's being controlled by and how that particular Kubernetes object is performing, I can click directly into this core DNS and view this replica set in a granular fashion. This creates a much more efficient environment for all Kubernetes hackers that are utilizing Lens. The ability to click and walk through each and every single object is very, very useful. Let's move along. So we're almost at the halfway point, and I want to talk to you guys all about what we've already reviewed and where we are going with the demo itself now. So we reviewed how to add a cluster, how to create a workspace, how to add an icon to our cluster to create a much more efficient environment within our smart console. So if I wanted to jump to my admin cluster, I can do so. If I wanted to jump to my Raspberry Pi, I can do so. If I wanted to jump to Minikube, I can do so. My staging cluster, and so forth. Coming back to our Lens demo, we've also reviewed the context-aware terminal, which allows us to automatically, yes, once again, automatically connect to the correct endpoint of our cluster. This reduces any human error that could be happening. We've also reviewed the pre-built-in Prometheus that Lens leverages from your kubeconfig file. And we talked about how Lens is leveraging your role-based access control from your YAML file. We do not build a new construct. We are leveraging, once again, your role-based access control from your YAML file. I think that's extremely important to note, as well as, again, the context-aware terminal, where we are automatically matching to the correct endpoint of the cluster. So from here, we're going to walk through a couple other things within Lens, but I do want to show you guys how we can deploy and install a Helm chart directly into our cluster with Lens, and also how we can port forward into that particular application. After we do this, we will get a sneak peek within our Lens extension API, which allows users and organizations to build extensions on top of Lens to, one, harness our user base. And as you guys know, it's over 93,000, and to increase the Lens's functionality, but also, again, harnessing our user base for your particular tool, product, open source technology that can sit on top of Lens as an extension. Okay, so let's move along. We have our daemon sets, our stateful sets, our jobs, and our cron jobs. Again, Lens allows us to filter and search in every single section and with every single Kubernetes object within our cluster itself. From here, we'll jump into our config. Take a look at our config maps. You can scroll, and of course, we can take a look at them. On the top, you can see the Kubernetes object config map, and on the right, you can see the name of that particular config map, when it was created, the namespace it's associated with, and of course, very importantly, our labels. Scrolling down, we can see the data associated as well to this config map, all in one place. I won't scroll through this whole thing. As you guys can see, it's very, very long. But we do have this functionality within Lens. Also, the next thing I want to show you guys is our secrets, which is very important, or your secrets. And again, you can only view these particular things based off of your role-based access control that Lens leverages from your YAML file. Is all of our secrets associated, the namespace they're associated with, the labels, the keys, the type, and of course the age. Filtering for a specific namespace, we'll do Stacklight. And immediately we can see we have filtered for this specific namespace, and we have 27 out of 85 highlighted here. Clicking into a secret, you get much of the same functionality as you did in the other Kubernetes objects when viewing them. You get the name, when it was created, the namespace, the labels associated, and of course, the secrets. Opening this, again, is based off of your RBAC that we leverage from your YAML file. You can show it real quick, and we can hide it, and we can close this. I'm pretty sure within this cluster, we don't have any resource quotas, HBAs, or pod distribution budgets, but we can take a look. We are filtered, so let's unfilter. And as you can see, we do not have any of these. Moving down to network, we can see all of the services associated, our endpoints, our ingresses, and our network policies as well. So if you guys haven't caught on yet, Lens allows us to filter and search within any section, creating a much more efficient environment for whoever is utilizing this tool and working within their cluster. From being able to click and view and jump into Kubernetes resource manifest, all without having to write any command line. Fantastic. Close this. Let's actually exit that, leave that. Here's our endpoints. I don't think we have any ingresses, and our network policies. You can take a look at our storage, our persistent volume claims. And once again, you guys can see that there are some things hyperlinked here, which immediately gives us the ability to walk to that Kubernetes object through a simple click. We've opened this pod. It's a Jenkins pod. You can see when it was created, the labels associated, the annotations, what it's being controlled by, and the nodes. You can always view the logs as well. And we can see various other details while scrolling. Okay, so let's actually move towards deploying a Helm chart within our cluster through Lens. So Lens leverages Artifact Hub, a public repo, online to pull hundreds, if not thousands, of different Helm packages that we can choose from. And yes, you definitely can bring your own Helm package if you choose to do so. Today, for this example, we'll download WordPress. We'll use Bitnami. We'll open the Helm chart package. And this is provided to us through, once again, Artifact Hub. And all of the details associated to this Helm chart is packaged for us. From the introduction to the prerequisites, installing the chart, the parameters of the chart, and various other details, as you guys can see. Again, anything that is hyperlinked is clickable. So for example, if we wanted to jump to our Kubernetes documentation, we can do so. From here, we'll install. It's a little smaller. Actually, let's just scroll through this for a second. You can see everything associated to this Helm. And we can click install. Immediately, Lens begins to install this Helm chart in the package directly to our cluster. And as you guys can see, it was successful. So there's three places where this lives. Lives under our charts or releases, view our Helm release, and our releases here. Clicking into here, you can see that we deployed and installed our Helm chart 24 seconds ago. And of course, you get various other details here as well. You can see the secrets associated, the service account, the config map, the persistent volume claim, the deployment, and the stateful set as well. And again, anything that is currently highlighted or hyperlinked is clickable. So I can click into my deployment and immediately get a granular view in the last hour of our WordPress deployment with the labels associated, the annotations, when it was created, and so forth. Again, we can scale through Lens while excuse me, while it leverages Kubernetes or uses Kubernetes if we choose to do so. So now I want to show you how we can port forward directly into this application. For demonstration purposes, I will move to my local cluster. This cluster is not a local cluster, so we will jump to our mini queue, which is my desktop cluster. And as you can see, I have my icon associated, so I know immediately where this cluster is within our cluster selector or our smart console. To port forward, we would go to our network, find the particular application, click our port, and it immediately opens up, as you guys can see. So as you guys can probably tell, I had this this Helm chart already deployed within my Minikube, so we did not have to install and deploy it. All I did was move to my network, to my services, and clicked our particular port. And again, Lens immediately launches, as you guys can see. So we're at 41 over the hour. So the last thing I do want to highlight for each and every single one of us is our Lens extensions. This is set to be released tomorrow. Currently, you can play with this through a release candidate that you can find on GitHub. But for now, let's see how we can add an extension and which extension we're going to add and the value of that extension. Scrolling to Lens at the top left, we'll click Extensions. And you can see I currently have an extension already installed, but we can find another extension. Yep, use config, and immediately Lens installs this extension on top of Lens, all in real time. So today I will be demonstrating the Mirantis Lens extension to Container Cloud. And what's useful about this extension itself is being able to add clusters to Lens from Mirantis Container Cloud immediately. So I'll sign here in real quick. And what we're signing into, obviously you guys can see the endpoint at the top, that's the URL. And then we're signing into our Mirantis Container Cloud instance to view which clusters we can grab from Mirantis Container Cloud. As you guys can see, we have several different clusters here from our default to our demo and our demo 2. So for demonstration purposes, I will grab 2 of these clusters, add selected clusters. They were skipped because they're already in Lens. Cool. And to view these clusters, we'll jump to our workspaces. And we can see that we have added the demo 2 cluster directly to Lens through the Mirantis Container Cloud extension. Voila. So this is one of the first extensions. There's many more currently out and available. And we really do hope that everyone begins to think about extensions that we can leverage on top of Lens to harness our user base for your particular technology tool or open source activity. Okay, guys, we're coming up to the witching hour. And there's one last thing I do want to highlight. I will jump back to my workspace for default. And this is our custom resources. Let's go back to my demo. And within our CRDs, we can take a look at Istio, Envoy, and other custom resources on top of Kubernetes if we choose to do so. I don't think I currently have any, but if you choose to do so, you have that functionality within Lens as well. So to bring it all home, if you're an application owner, a developer, an operator, Lens gives you a much more granular view into your cluster, how your application is performing. You can cordon, you can shell into a node, you can scale up and down different deployments all in real time without having to write any command line. Awesome. Thanks, guys. From here, I do want to jump into a quick slide. Let's see if it'll actually let me scroll. And what we can do instead is we can just open it up this way. So here's our contact information, where you can find the GitHub repo, or you can download Lens, my email, the Lens email, and please, please, please join our Slack community for posting issues with Lens, troubleshooting, maybe ideas that you would like to see that would come to Lens, anything of that particular nature. We are more than willing to listen to the community and get your feedback. This would be greatly appreciated. We want to listen to everybody. We want to build this together, and we want to make this the greatest Kubernetes IDE. Questions?
I am Nick Chase, also from Mirantis. I'm going to go ahead and facilitate the questions here. Thank you very much, Edward. That was very informative. If you have questions, please go ahead and drop them in the chat or the Q&A, and we will try and get to them. So let's go ahead and look at this list here. Let's talk, there seems to be a bit of excitement about these extensions. Somebody wants to know, can I create my own extensions?
Yes. Yes, you can absolutely create your own extensions. So our documentation is posted on GitHub currently, and we are more than willing to work with you to actually help you build the extensions itself. So let me once again share. We always have this issue. Share our contact information, and I can also provide the documentation if you email me where you can build a Lens extension. And if you go to our website, kateslens.dev, click partners, you can request to become a partner. Really what that means is that you want to build an extension, become part of the Lens extension community. Fill out this form and we will provide you guys with documentation, potentially a discovery call with the technical team that built Lens as well, and anything else you guys need to help onboard you guys to build your extension. So the answer to that is yes.
Okay, let's go ahead and look back at this list. How does Lens handle access control to your Kubernetes cluster? So how does security work?
Got it. Yeah, so Lens will automatically inherit the access control from your kubeconfig file through the role-based access control of that YAML file itself.
So basically whatever security the user has, if they were accessing Kubernetes through any other means, Lens will honor that.
Correct. I see another question here from, and I apologize if I butcher it, from Santosh. I couldn't see clusters or nodes in Lens IDE as shown. What could be the reason? Currently showing empty CPU or memory or other details, though it's ready. So Lens auto detects your metrics and your Prometheus from your YAML file. And if you do not have that currently within your YAML file, you can still install Prometheus directly through Lens. So the way you would do this is in settings of your cluster. You have this metric stack and you can install it here.
Okay. All right. Excellent. What different flavors of Kubernetes clusters does Lens work with?
Oh, that's a fantastic question. So Lens works with any Kubernetes distribution from GKE to EKS to Rancher, Mirantis Container Cloud, and any approved CNCF certified Kubernetes distributions.
Okay. That include K0s?
It does. That does include K0s.
Just for those of you who haven't heard of it, we also were involved in the whole K0s launch a couple days ago. So, okay, so let's see here.
I see another question, Nick. Is it possible to set up the default shell, fish or ZSH, and use these features? It's not currently possible. Lens will default the terminal. Lens will default and use the terminal in the current environment. So please feel free to open up a request on Lens's GitHub, and hopefully we can build that very, very soon. That's an excellent question.
Is Lens available as a web version, something that I could run in cluster for all my end users?
No, it is not. Lens is a desktop application. So unfortunately, it is not a web application. It's a desktop application, and you can download it at our GitHub repository, Lens app.
Okay. Oh, let's see. Let's see if I got here. What is this? What is the Mirantis Container Cloud tool you used in the demo? Seems like it manages multiple Kubernetes clusters.
Yes, yes. So Mirantis Container Cloud, what I highlighted in the demo was the extension to Mirantis Container Cloud. Mirantis Container Cloud provides a single pane of glass to help developers and operators stand up and maintain their Kubernetes clusters anywhere. So think of it as a managed Kubernetes offering. That's the way I would explain it. Yeah, I don't see any other questions. It looks like Jose asked a question that was already answered. I can answer it again. So if you don't have Prometheus set up within your YAML file, you can install it here within Lens. Where did it go? Here. Or sorry, let me go back to my settings. Yeah, and our metric stack, you can install it here, and Lens will automatically install a Prometheus onto Lens, so you can get the CPU and the memory to show up as we've shown. If I go jump to my demo cluster like this. But currently, this is leveraging the auto detect feature within Lens, and it's leveraging the metrics that are built within my cluster file itself, my YAML file.
All right, excellent. Well, if we don't have any other questions, oh wait, looks like something just popped up. No. No, that was the duplicate. Okay. So, yeah, so I suppose if we have no other questions and going once, going twice, sold. So, Edward, oh, no, wait a minute. We do have one more question. Oh.
Is there a way to log into Pod to see its content and internals through Lens? That's an excellent question. You can. I believe you can. So you can take a look at your pods. You can select a pod, and you can view the logs associated to see what is currently happening within the pod itself. Does that answer your question? Yeah, you can exec directly into the pod, or as I'm showing here, the logs itself. This will help you view exactly what is currently happening. And again, you can save your logs directly to your desktop if you choose to do so. You can also search within your logs as well. So index.html, it highlights everything here. So the answer to your question is yes.
Excellent. Okay. All right. Any other questions before we take our leave?
And once again, I do want to mention and show you guys where you guys can find Lens currently. So as you guys can see, you can find it at GitHub, and we are currently planning on releasing our GA version of Lens 4.0 tomorrow or the next day. Currently, there is a release candidate that is out, and you guys can play with that as of right now. And that is currently what I'm working off of for this particular demo itself. So if I jump into About Lens, you guys can see it's a release candidate 4.0. And that's, once again, why we were unable to highlight the distribution version of your Kubernetes. But for this particular cluster, I know it's vanilla. And once GA is out, you guys will also be able to see that your distribution version.
All right. Well, you want to take us home, Edward?
Yeah, sure, guys. So thanks for sitting through the entire demo. I know it was packed with a ton of different things, from walking our Kubernetes objects through clicks and filtering, also highlighting that Lens has a pre-built-in context-aware terminal, which auto-magically matches to the correct endpoint of the cluster. Lens has pre-built-in Prometheus auto detect as well to bring you metrics all in real time for the last hour to see how your cluster is performing. Lens also allows you to install and deploy a Helm chart all in real time, as we highlighted here through our apps. This is the repo. We're utilizing Artifact Hub. You can search for your particular Helm chart, grab it, install, all through several clicks. And we also walk through our Lens extensions feature, where I really suggest and I push each and every single one of you to begin thinking about what kind of extensions can sit on top of Lens if you choose to do so. So with that, I want to thank each and every single one of you for joining our webinar today of how to take the pain out of multi-cluster Kubernetes with Lens. And I hope each and every single one of you go ahead and downloads it. And I also hope that it creates a much more efficient use of your time when working with Kubernetes and the current clusters. Thank you all. It was very, very exciting. And I hope you guys enjoy the rest of your day from wherever you are in the world. Stay safe to your family and your friends.
Awesome. Thanks so much, Edward, for the great presentation. And thank you, Nick, for supporting today. And thank you, Michelle, for being on the back end and helping as well. As Edward said, hope everybody has a great day. Stay safe out there. A reminder that you can find the recording and the slides from this presentation posted later today to the CNCF webinars page. We hope to see you at a future CNCF webinar. Thanks, everybody.
Thanks, everyone.